All right, so now we've got an interesting question where we're going to look at some quadratic functions, but again, there's a little bit of a twist here. Okay, so let's have a look at that question. So we've got a graph of a quadratic function that touches the x-axis. All right, so it doesn't cross it. That's important. It has a turning point at 3, 0. We want to graph two parabolas which apply to this description and find equations for them. And then we need to answer the question of how many examples are possible. So let's address the first part, and we're going to go with the two most obvious types of graphs we can get here. So we know it has a turning point at 3, 0, and it's not going to cross the graph at that point. So therefore, if I draw a point there, I know that that's either going to be the minimum or the maximum of my graph. So let's start off one that would look like a maximum. All right, come down like that and come back up. Now a potential example for this line could just be simply x minus 3 squared. And the reason for that is because the graph has been shifted 3 units to the right. All right, so if it has moved 3 units to the right, our turning point, as stated before, is going to be 3, 0, and our graph is in the form of a turning point which would be hk, and of course if we were to represent that as an equation, we'd always write x minus h squared plus k. So in this case, minus h is going to equal 3, so therefore h equals minus 3. That's why our graph is x minus 3 squared as opposed to x plus 3 squared, even though it goes 3 units in the positive direction. Okay, so that could be an example of one of the graphs. Another example of this graph could be minus x minus 3 squared, which would be the same type of graph, just upside down. Now again, when we're sketching these graphs, we'll need to also put in our y-intercepts, and we would do that by subbing 0 into both equations. Okay, so for the first one, we're going to get 3 squared, which is 9. So on our graph, we will plot 0 and 9. So we'll say that that's it. Again, you'd want to be more meticulous using a ruler just to make sure at that position. Whereas here, it's going to be the same answer, but because we've got a negative out the front, it's going to become negative 9. So our graph down here would have a y-intercept of 0 and negative 9. And of course, these parabolas then continue on forever. All right, so there's two potential examples we could look at. But then the question then asks us, how many possible examples could we get? Well, simply, the answer to this one is there's infinitely many examples of different graphs we could do. Because our graph is always in the form, when we're talking about in turning point form, is in the graph of a times x minus h squared plus k. So we addressed this a little bit earlier. Now, the value of a could be anything. And we know that if a is more than 1, we get a narrower graph. And the higher the number for a, the more narrower the graph becomes. So therefore, the smaller the number, say for instance when a is less than 1, but also more than 0, then our graph becomes more wider as the number for a gets closer to 0. Okay, so we could have infinitely many examples, as I said before, based on the number that we use for a. So we could have a graph like this, because it still has a turning point at 3, 0. This one is more likely to have a number for a which is higher than 1. So this would be something, for example, could be 3x minus 3 squared. Or on the bottom, we could also do minus 3x minus 3 squared. Or we could go for something wider. So for example, you have something wide that comes out like this. So an example of this might be 1 over 3 x minus 3 squared. Or down the bottom, we might have, again, the same type of graph. And instead, we're going to have negative 1 over 3 x minus 3 squared. So there's infinitely many numbers we could have for a. So as a result, we could have infinitely many amount of parabolas that have a turning point at 3, 0. All right. Hope that helps.